Hello, lovely students. We are going to talk about chemical properties of ethanoic acid or acetic acid. We all know that ethanoic acid is found in vinegar naturally. So it's an alkanoic. It belongs to the alkanoic family or carboxylic acid family. So let's get to work. The first chemical property we're going to look at is reaction of ethanoic acid with metals. We all know that acid reacts with metals to liberate hydrogen gas. So ethanoic acid is an organic acid. So it also shares that kind of property with inorganic acids. So it will react with a metal to liberate hydrogen gas. In this case, ethanoic acid is reacting with sodium to liberate hydrogen gas. In the second case, ethanoic acid is reacting with zinc to liberate hydrogen gas. Then the two other products formed here, we have sodium ethanoate, a salt. We also have zinc ethanoate, also formed in the second reaction. Now the next reaction we're going to look at is ethanoic acid reacting with sodium triazocarbonate or reacting with triazocarbonate 4 or hydrogen triazocarbonate 4 in the second reaction. Recall that inorganic acid reacts with triazocarbonate 4 to liberate hydrogen gas. So the same thing goes for this inorganic acid that is called ethanoic acid. Is reacting with sodium triazocarbonate 4 to liberate carbon 4 oxide gas, and sodium ethanoate is also formed, a salt. In the second case, we have sodium hydrogen triazocarbonate 4 reacting with ethanoic acid. Among the product, we have sodium ethanoate and carbon 4 oxide is also liberated. This particular reaction can be used to test a specimen solution. If you have a specimen liquid and you want to know, they tell you that it's an organic compound and they give you sodium triazocarbonate 4 to react with it. So if it liberates a carbon 4 oxide, is likely an alkanoic acid. Now the next chemical property we're going to look at is ethanoic acid reacting with sodium hydroxide. This reaction is a neutralization reaction. Recall that when you were taught acid base and salts, there's a type of reaction called neutralization reaction where an acid reacts with a base to form salt and water only. So even ethanoic acid and acid will also undergo this kind of reaction. Ethanoic acid reacting with sodium hydroxide to give us sodium ethanoate and water as products, salt and water. Okay, now the next one we are going to look at decarboxylation. This reaction is called decarboxylation because we are going to remove carbon 4 oxide from this compound here. So when you have a salt of ethanoic acid like sodium ethanoate, you react it with soda lime. Soda lime is actually quick lime slaked with caustic soda or slaked with sodium hydroxide. So that's the meaning of soda lime. Now, usually when we talk about slaked lime, we talk about quick lime slaked with water. But soda lime is actually quick lime slaked with sodium hydroxide. In this reaction, you have to eat a mixture of soda lime with sodium ethanoate, and at the end of the day, you get methane and sodium triazocarbonate 4. The next reaction we're going to look at is esterification reaction. This reaction is called esterification reaction, and there is formation of an ester in this reaction. Esterification reaction is a type of reaction in which a carboxylic acid, in this case ethanoic acid, reacts with an alkanol, in this case ethanol, in the presence of a mineral acid as a catalyst. The catalyst here is tetraoxosulfate 6 acid to form an ester and water only. The ester here is ethyl ethanoate. So ethanoic acid reacts with ethanol in the presence of tetraoxosulfate 6 acid to give ethyl ethanoate and ester with water only. Then the last reaction we are going to look at here is reduction reaction. we want to try to use a strong reducing agent. The name of this strong reducing agent that is going to supply our hydrogen meant for the purpose of reduction is lithium tetrahydroaluminate 3. That is the name of this reducing agent. So it will supply hydrogen here. The ethanoic acid will first of all be reduced to ethanol, an alkanal or aldehyde. Then it will finally be reduced to ethanol. Well, the reverse process is oxidation. Recall that if you oxidize ethanol with, for instance, K2Cr2O7, you first of all get ethanol, then finally ethanoic acid. So that's the reverse process. Thank you.